These models have read almost everything, nearly the entire public internet, most of the books worth digitizing, a staggering share of everything humanity has ever written down, which leads to a strange and very real question. What happens when there's nothing left to read? We've followed Claude from how it's built, through scaling and reasoning, to how we measure it. And underneath all of it sits one raw ingredient we've mostly taken for granted: data. Today, the data wall, the looming limit on the human text these models feed on, and the risky, fascinating ways the field is trying to get around it. We'll cover just how much data these models eat, why we're hitting the edge of what exists, the idea of models making their own data, the danger that creates, and the shift from more data to better data. Start with the sheer scale of the hunger, because it's genuinely hard to believe. Modern models train on trillions of words, not thousands, not millions, trillions. To get anywhere near that number, labs vacuum up enormous slices of the web, news articles, entire libraries of books, forum threads, source code, conversations, reference works, the accumulated written output of the whole species, poured in as raw material. And remember the key lesson from scaling: to train a bigger model properly, you don't just want more parameters, you need a matching flood of more data to go with them, roughly in step. So every jump in model size comes bundled with a jump in appetite for text. For years, this was completely fine. The internet was vast and mostly untouched, an ocean nobody had come close to draining. Each new model could simply drink more than the last, and there was always more waiting. But an ocean, however impossibly huge it looks from the shore, is still finite, and these systems have been drinking it down astonishingly fast. Here's the squeeze. The total amount of high-quality human text in the world is large, but it is limited, and it grows only slowly, at roughly the pace humans actually sit down and write things worth training on. The model's appetite, by sharp contrast, has been growing explosively, doubling and doubling again with each generation. Put a fast-rising line of demand against a slowly rising line of supply, and eventually, inevitably, the two lines cross. That crossing point is what people mean by the data wall, the moment when the best models have effectively consumed most of the good text that exists, and there simply isn't a fresh, untouched ocean to point them at next. You can always scrape the lower quality corners of the web, but pouring in junk often hurts the model more than it helps. And notice what this does to the whole scaling story we told earlier. For years, the binding bottleneck was compute. Could you afford enough chips, enough electricity? Now, a completely new bottleneck steps forward and takes its place. The question is no longer just, can we build a bigger model? It's, do we have anything left to feed it? So, if the world isn't producing text fast enough, here's the audacious idea that follows. What if the models make their own? This is synthetic data, and it's one of the most active frontiers in the entire field right now. The intuition sounds almost like cheating, but it's real. A capable model can generate brand new problems and then work through them, and wherever the results can actually be checked, a math answer that's verifiably correct, code that genuinely runs, a reasoning chain that arrives at a confirmed solution. Those verified examples become fresh, legitimate training material. A stronger model can even generate clean, high-quality data specifically to teach a smaller one, handing down its ability like a mentor. And tie this straight back to reasoning. A model that thinks carefully through a hard problem and lands on a checkable answer has, in effect, just produced a brand new worked example that never existed anywhere before. The dream is a kind of bootstrap, a system that helps generate the very lessons it then learns from, loosening the grip of that finite human ocean and letting progress continue past the wall. But feeding a model a diet of its own output is playing with fire, and the failure mode even has a name: model collapse. Picture a photocopy of a photocopy of a photocopy. Any single copy looks basically fine, but tiny errors compound with each pass, fine detail washes out, and after enough generations, you're left with a gray, featureless smear. The same thing can happen to a model trained naively on text generated by earlier models. The rare, the unusual, the genuinely surprising gets quietly smoothed away. The output drifts toward a bland average of itself. The diversity that made it useful slowly dies. Train a model on its own echo for long enough, and it forgets the richness of the real world it originally learned from. This is exactly why synthetic data can't just be a model talking to itself in a mirror forever. It needs an anchor to reality, some reliable way to check that a generated example is actually correct, actually useful, actually new information, and not just a confident restatement of what it already knew. Without that grounding, the copy of a copy problem takes over, and the system gets confidently, uniformly, catastrophically worse. So the real answer isn't simply more text, it's better text. And this represents a genuine shift in how the whole field thinks about the problem. For years, the reflex was to hoard, grab absolutely everything, the entire web, dump it in, and let sheer scale sort the good from the bad. Now, the most valuable moves are about curation, carefully filtering what goes in, aggressively throwing out the junk and the near duplicates, keeping only the clearest, richest, most reliable material. A smaller pile of excellent data can decisively beat a mountain of mediocre data. And the truly precious resource becomes the stuff that's genuinely hard to fake or synthesize. Real expert human knowledge, carefully verified reasoning, high-quality human judgment about what is actually true. Human effort doesn't leave the loop at all. It moves up the loop toward the rare, the expert, and the trustworthy. The data wall, in the end, isn't really a dead stop. It's a forcing function, pushing the field away from raw quantity and toward quality, verification, and craft. From carelessly drinking the whole ocean to patiently distilling it down to what matters. That's the data wall, the limit we're hitting, and the risky, ingenious ways around it. If this clicked, subscribe. Next, the finale. Put every single piece of this series together. Scaling, reasoning, evaluation, data, and you get systems that help build their own successors. Where this whole story has been heading.